Similar to one-dimensional motion, we can examine two-dimensional motion and three-dimensional motion using a velocity vector. So if we have some position at some initial time, p1, defined by this velocity vector r, and then some later position, p2, at some later time, at some time t plus delta t, then we can define the velocity, the average velocity, as the difference between their positions, so that's the displacement, divided by the amount of time it takes for us to get from the initial to the final position. So displacement over time, that's our average velocity, and here that's displacement delta r over delta t. We can look at this component-wise and see that you can split this up into x, y, and z components. And so you get your average velocity in the x direction is equal to delta x over delta t. Similarly for y and similarly for z. If we want instantaneous velocities, we can do what we did for one-dimensional motion and just do it for the vector here. So to remind us, in one dimensions, we said that we can take the limit as this time interval delta t gets very, very small. So in one dimensions, it looked like this. Delta t goes to 0, we take that limit, and we end up with the time derivative of our x position. We can do the same thing with this displacement vector and say that my velocity vector is equal to the limit as our time interval goes to 0 of that change in position over our change in time. And as you take that limit, it becomes the derivative with respect to time of that position vector, where that position vector, to remind us, is given by x in the I hat direction plus our y position in the j hat direction plus our z position in the k hat direction. So when we take our time derivative, well, our time derivative of our x position gives us our velocity in the x, and our time derivative of our y position gives us our velocity in the y. So we can represent our velocity vector as our velocity in the x in the I hat plus our velocity in the y in the j hat plus our velocity in the z in the k hat, where vx is dx dt, vy is dy dt, and vz is dz dt.